The sun dips below the Martian horizon, painting the sky in hues of dusty rose and muted gold. It's a breathtaking sight, captured by robotic rovers millions of miles away. But the beauty of a Martian sunset belies a fundamental difference between Earth and its reddish neighbor. On Mars, the sun's embrace is a distant whisper, compared to the life-giving warmth we experience on Earth. Mars, on average, receives only about 43% of the solar energy that bathes Earth. This means that even at its brightest, a sunny day on Mars would feel like a dimly lit room compared to the sun-drenched landscapes we know. Mars, orbiting farther away from the sun than Earth, receives a diminished share of its life-giving rays. The inverse square law, a fundamental principle in physics, dictates that the intensity of light decreases with the square of the distance from the source. In simpler terms, double the distance, and you get only a quarter of the light. This distance, coupled with Mars's thin atmosphere, creates a challenging environment for life as we know it. While we might don spacesuits and venture out to explore its dusty plains, transforming Mars into a second Earth would require feats of engineering and technology that border on science fiction. But that doesn't mean we can't dream, can't explore the tantalizing possibilities that lie at the intersection of human ingenuity and the cosmos. Imagine standing on the surface of Mars, gazing up at the sky. The sun, a small pale disk, hangs low in the sky, casting long, eerie shadows across the rust-colored landscape. This is the reality of solar illumination on Mars, a faint echo of the sun's power that we often take for granted here on Earth. On Earth, sunlight drives photosynthesis, the process by which plants convert light energy into chemical energy, fueling the web of life. It warms our planet, dictates our seasons, and influences our weather patterns. On Mars, however, the sun's energy is a scarce resource, a limiting factor for any future attempts at terraforming or establishing a permanent human presence. To put this difference into perspective, imagine trying to power a city with a handful of batteries, while your neighbor enjoys the uninterrupted flow of electricity from the grid. That's the challenge we face on Mars, a chronic energy deficit that limits our options and forces us to think creatively about how to harness and enhance the sunlight that does reach the red planet. Just as we've developed technologies to thrive in Earth's most extreme environments, we can apply our ingenuity to overcome the challenges of a dimly lit Mars. The key lies in understanding the science of light, harnessing the power of reflection and refraction, and perhaps even daring to reshape the Martian atmosphere itself. Could we capture a greater share of the sun's energy by deploying giant mirrors in space, strategically positioned to reflect sunlight onto specific regions of Mars? Imagine a constellation of these orbital mirrors, each spanning miles in diameter, working in concert to illuminate a chosen Martian city or agricultural zone. These mirrors, made of ultra-thin reflective material, would act as celestial magnifying glasses, concentrating sunlight onto the Martian surface. The challenges, however, are as immense as the mirrors themselves. Constructing and deploying mirrors of this size would require advancements in space-based manufacturing and assembly that are currently beyond our reach. Maintaining their delicate balance in orbit, ensuring precise targeting of reflected sunlight, and protecting them from micrometeoroids and solar radiation would pose continuous engineering hurdles. Despite these challenges, the allure of space-based mirrors remains strong. Further research and development in this field could one day make this ambitious vision a reality, adding another tool to our toolbox for transforming Mars into a more habitable world. While space-based mirrors offer a tantalizing solution, perhaps the most audacious idea for increasing sunlight on Mars involves altering the planet itself. By thickening the Martian atmosphere and changing its composition, we could theoretically enhance the greenhouse effect, trapping more solar radiation and warming the planet. This process, known as terraforming, aims to transform Mars from a cold, arid desert into a more Earth-like environment. By introducing super greenhouse gases into the Martian atmosphere, we could potentially trigger a runaway greenhouse effect, melting the polar ice caps, releasing trapped carbon dioxide, and thickening the atmosphere to the point where liquid water could once again flow on the surface. However, terraforming is a double-edged sword. While it holds the promise of creating a more habitable Mars, it also carries significant risks and ethical considerations. The unintended consequences of such a massive planetary experiment are difficult to predict, and could have devastating, irreversible effects on the Martian environment. Section 5. The Ethical Dilemma. The prospect of terraforming Mars raises profound ethical questions about our role as stewards of the cosmos. Do we have the right to reshape another planet in our image, potentially disrupting any existing Martian life, however microbial, to create a new home for ourselves? On the one hand, proponents argue that it's our moral imperative to explore and utilize the resources of our solar system to ensure the long-term survival of humanity. They view terraforming as an extension of our natural drive to explore and settle new lands, a continuation of the human story on a cosmic scale. On the other hand, critics argue that terraforming represents a form of cosmic colonialism, an arrogant assertion of human dominance over the solar system. They worry that we may unwittingly destroy existing Martian life, or irrevocably damage the planet's delicate ecosystem in our quest to create a second Earth. The decisions we make today about Mars will have far-reaching consequences, shaping the future of humanity and our place in the cosmos. Section 6. The Oasis Within. While the ethics and logistics of terraforming Mars are still under debate, there are smaller-scale solutions for increasing sunlight and creating habitable environments on the red planet. One such solution lies in the concept of bioregenerative life support systems, more commonly known as greenhouses. Imagine stepping inside a Martian greenhouse, a verdant oasis amidst the desolate landscape. Sunlight streams through transparent panels, illuminating rows of leafy greens, vibrant vegetables, and even flowering plants. Here, carefully controlled environments mimic the conditions necessary for photosynthesis, providing food and oxygen for future Martian colonists. These greenhouses, powered by a combination of solar panels and advanced energy storage systems, could serve as vital hubs for food production, research, and even psychological well-being. Greenhouses represent a practical and achievable step towards establishing a human presence on Mars. They offer a sustainable and relatively self-sufficient way to produce food, recycle waste, and create pockets of Earth-like conditions on a planet where resources are scarce. Section 7. The Power of the Sun. In our quest to illuminate Mars, we must not overlook the most abundant source of energy in our solar system, the Sun. While Mars receives less sunlight than Earth, it still receives enough to power a civilization, provided we develop the right technologies to harness it effectively. Solar panels, already a familiar sight on Earth, will play a crucial role in powering future Martian settlements. These panels, designed to withstand the harsh Martian environment, will convert sunlight directly into electricity, providing a reliable and sustainable energy source for everything from life support systems to scientific instruments. But solar power on Mars faces unique challenges. Dust storms, a common occurrence on Mars, can blanket the surface for weeks, reducing sunlight and hindering solar power generation. We'll need to develop self-cleaning solar panels, advanced energy storage solutions, and perhaps even explore the potential of space-based solar power, beaming energy down to the surface from orbiting satellites. Section 8. A Martian Future. As we stand on the cusp of a new era of space exploration, the question of how to illuminate Mars, both literally and figuratively, will continue to captivate our imaginations. Whether we choose to pursue ambitious terraforming projects, focus on smaller-scale greenhouse solutions, or rely on the power of the sun, one thing is certain: our journey to Mars will be a testament to human ingenuity, determination, and our unquenchable thirst for knowledge and exploration. The challenges of illuminating Mars are significant, but they are not insurmountable. By pushing the boundaries of science and technology, by embracing ethical considerations and fostering global cooperation, we can make the dream of a brighter future on Mars a reality. And perhaps, in the process, we'll learn more about ourselves, our place in the cosmos, and the boundless possibilities that await us among the stars.